So tonight is night one of JavaScript, and I will say from the get-go, we have a lot of ground to cover tonight. So don't panic. We will be having, I think, a longer lecture than usual, but I'm going to try and lay the groundwork as best as we can. Understand, though, that tonight you're going to see a lot of topics. We're really throwing a lot at you. The first time you see something, you should not expect to have a deep comprehension of it. So for those of you who have outside programming language experience or outside JavaScript experience, the pace for tonight will probably feel comfortable. I'm going to be completely honest. For those of you who are seeing this as your very first programming language, the pace tonight will be intense. But just try and keep up, do your best to comprehend it, and understand that in later nights in this sprint, we will have opportunity to review some of these concepts and help solidify them. So the most important takeaway here is stay calm, enjoy it. Don't jump to crazy conclusions in your head about what it means for your future if you're struggling tonight. It is a lot of material, but we're all going to do our best together. So let's jump on in. Before we look at the nitty-gritty of JavaScript, I want to talk about the idea of a programming language. So as mentioned, unless you have outside experience, this is your first look at a programming language. And as always, for those of you who do have JavaScript experience, just sit back and enjoy. I want to see the people in the questions and discussion thread, the people who are seeing this for the first time. So if you do have outside experience, just sit back and enjoy the ride and let the rest of us work on it together. All right, so as mentioned, we have, of course, seen other languages already. We've explored HTML and CSS, but this is our first true look at a programming language. So what makes a programming language different? How is this going to be different than what we've seen so far with HTML or CSS? Who can either tell me or venture a guess in the discussion thread? It's harder. Let me rephrase that slightly. There's more we can do with it, which means, yes, there's more to learn, but on the flip side, there's more possibility. So that is true. Can anyone get a little more concrete than that? It gives functionality, does certain jobs. It's like the electronics to our house. It's fun. All right, all good stuff, but let's get a little more concrete here. So markup languages are designed to display content. So they're designed for a really specific job. Specifically, the ones we've been working with, HTML and CSS, are designed to display web content. As we know, HTML actually builds the structure of our web page, CSS styles it. But no matter how good you got at either of those languages, if I were to tell you to build, let's say, a chat bot or a chess bot or any sort of bot in HTML or CSS, you would be in trouble because there's simply no way to do it. So these two languages we've worked with so far are very narrow in their scope. They're designed to do specific jobs. Programming languages are more like catch-alls. They all come with a certain set of core functions, but you can essentially do anything with them. So JavaScript, it's kind of like the sky is the limit. If you get good enough at JavaScript, you can do almost anything in it. That doesn't mean it's the ideal language, but you can do it. So all programming languages, whether it's Java or Ruby or Python, they all come with a certain set of things that we'll learn tonight. Things like variables, branching, loops. And it turns out that with this basic logic, you can build anything. So that's cool. We're teaching you night one of the skill that will allow you to do anything that's programmable. So that's pretty cool. But as mentioned, just because you can do stuff in JavaScript doesn't mean you always should. So JavaScript is a web development language, first and foremost. So who can tell me, you've kind of already gotten at this, a couple of you, how does JavaScript fit into web development? What piece of the web development puzzle does JavaScript provide? We know it's not really the styling piece because we already did that. So what piece of the web development world will JavaScript allow us to do? Functionality and user interaction. Perfect. So when we're thinking about what you'll be really going over for the next few units is how to use JavaScript to make your web page interact with the user. So that means, what happens when you actually click a button? What happens when the data loads? What happens when you submit a form? Even some advanced functionality on things like covers. So essentially, what we're learning is the base skill that will allow us to make our web pages interactive. So we're really in this not to just create static web pages like we've seen so far, but to create apps, to create things that can do advanced, sophisticated things. So think of the next 2 weeks, think of this intro to JavaScript sprint as being the building blocks so that you can do all sorts of cool stuff with web content. So on one hand, for the next 2 weeks, we won't be focusing on web functionality. We'll just be looking at JavaScript on its own, the basics of JavaScript. So that's what the next 2 weeks are focused on. But when you come back for the next unit, all the pieces are going to come together and you're going to see how this fits into the web development puzzle. All right, so let's go ahead and I will share my screen and we will get to it. So actually, one last question for you guys. I always try to get you guys to ask this question whenever I introduce a new language. And the question is, how is the code read? So this is an easy question to neglect, but I think that when you ask this question, it forces you to make sure you have a deep understanding of what you're working with. So we know that when you are working with HTML, all you have to do to read the code is open the page in the browser. We have learned that with CSS, you can link a CSS document to a HTML page and it will be read. So how is JavaScript going to be read? When we're working with JavaScript, we could always open up our VS Code and create a .js document. So this one's actually a little tricky. Just like CSS, one of the ways that JavaScript can be read is by linking it to your HTML page. So just so you guys know, that's kind of your standard way in web development that JavaScript is read, is linking it, just like we did with CSS, you link it in. However, we won't be doing that yet. So there's a couple workarounds. One is we can always run JavaScript standalone on our machine using Node. Remember, we kind of touched on what Node was last week. And so, for example, for the homework tonight, you will be doing it that way, and I'll show you how to do that at the end of tonight. But because we like shortcuts, at least at the beginning, we'll be using a tool called Replit. So you guys should all go into Replit. And if you want, I will just post that right now. This is totally blank. It's just a JavaScript REPL. So I'm going to post this in the main channel in Slack. So if you guys want a nice, easy starting point, you can go ahead and fork this. You could also say new REPL and create a new JavaScript REPL if you'd like. They'll both get you to the same place. So this will allow us to run JavaScript without having to worry about the command line, without having to worry about an HTML page. This is a nice shortcut for getting used to JavaScript. So we will be focusing on this throughout the lecture tonight. But I want you, as with sandboxes, don't get too comfy, because remember, it does get more complex once we get into the challenges and when we get into full-on code base. But this will be a great place for us to go over the fundamentals. All right, so let's start by talking about variables. Now, you guys have already seen a little taste of how variables work inside of in working with our preprocessor less. So, but now we're really going to take a look at how variables work in JavaScript. And as mentioned, even though we're focusing on JavaScript, variables are a concept that you would see in any programming language. So who can tell me what a variable is? And once again, if you have experience with programming languages, this would be a good time to sit back and be quiet and enjoy and let everyone else contribute. So what is your understanding of what a variable is in computer programming? It depends. Ha, I like that. Very clever. That's it's a vague answer, but it's actually kind of a brilliant answer. So a variable really is just a storage place for something else. So we don't really know what it is. I like this. A variable is a term that stores info that a computer can use later. That's a great definition. So just like when we wanted to say store a color name in CSS that we might use later throughout our less code, that's the general principle of a variable. So let's say that I knew I wanted to use my name multiple times throughout my code. I might say const name equals Deandra. So let's take a look at this statement. I've named a variable called name, and it points to the string Deandra. So later, if I access the variable name, it's going to resolve to Deandra. In other words, this is just a stand-in. We've created a stand-in word that's going to point to some other object. So that is the basic principle of a variable. And this is really critical, this concept in programming languages, is that we have bits of code that point to other things that we can substitute in interchangeably. Yep. So let's talk about the ways to declare variables. Actually, before I talk about the keywords, let's talk about different variables we might have. So we have the types of things we can store in variables depend on types. So we have data types. Once again, we're going to focus on JavaScript, but this is true in any single programming language we have. So there are different types of things we can create. So this chunk of text that I put my name in, this is something called a string. A string refers to any bit of text. So it could be a single word, it could be my full name, it could be a sentence, whether or not the sentence is entirely true or not. So this is what's called a string. You'll see it in single or double quotes. So this is one of the data types we will be working with, is a string. So anything that could even be a bunch of nonsense characters. So as long as it's declared in quotes, we're working with something called a string. Other data types. We might want a number, for example. So we could do age and set that to a number. So we're not only able to store text in these variables, we can also store numbers. Numbers are pretty great because we can actually use them for mathematical operations and stuff like that. So we have strings, we have numbers. And we also have something called Booleans. So fascist leader equals true. A Boolean just refers to either true or false. So it's really the simplest of the data types. When we want to keep track of something that's either an on or off, yes or no, true or false, we could use a Boolean. Yes, and as far as if we would use const for age, it depends on the context, but I don't want to get into const versus let just yet. I will get there in a moment. So, and then there's two other primitive data types, which are null and undefined. So for example, if we did something like JavaScript knowledge, we might set this to null because you might want to see how I do tonight before you give this a value. So we have null and undefined as values that can stand in for missing data. There is a difference between the two of these, but for time's sake, I want you to, for now, just understand that null and undefined are these two different data types, and they both work for missing data. We can talk later on about the subtlety between the two of them, but that's not really necessary for tonight. Yep. So these are the basic data types. We'll cover some more advanced ones later tonight. So when you're thinking about the types of objects that can exist in JavaScript, these 5 are going to be our starting point. And remember that a variable is just something that points to one of these values. So for example, if I were to use the fascist leader variable, what will this resolve to? What value does this variable point to? Yep, the value of true. And if we run our code, well, something has gone wrong here. I think I spelled something. Yes, I spelled fascist wrong. Not a very good fascist leader if I can't even spell fascist. If we spell everything correctly and look this up, we can see that this does resolve to true. So once again, these variables are just pointers. All right, you guys are very eager to talk about const versus let. So let's go ahead and discuss that. So the syntax for declaring a variable is we use the keyword const, the name of the variable, which this can be anything as long as it's not a reserved word. So you couldn't try to name a variable const or true or null, but almost anything you come up with is going to work. And then you use the single equals for assignment, and then whatever value you want to assign. So think of what's on the right side as being the value and what's on the left side as being the name. All right, so I have used the keyword const, and that should be your default way of declaring a variable. Now, const stands for constant, and it means that this value is going to be fixed. So if I tried to change my name to, I was like, hey, you know, I think I'd rather be Amanda. This is not allowed. So we get an error over here, assignment to constant. So we can't reassign this. This is stuck. And it turns out that actually this is a good thing. So we want to use constant most of the time to declare variables because, as it were, life can get really confusing if we're assigning and reassigning variables. So a good rule of thumb is to stick to using const, and once you've assigned this variable, you're done. However, there are certain cases where that's not a good idea. We'll go over some examples tonight when we do looping, but one great example would be age. Now, if this were designed to keep track of me in this slice of time, const age might be a good choice. But let's say that this was meant to keep track of information about me over years. I'm not always going to be 28. So we might want to change this to let. The only difference between let and const is that we can reassign let. So if later I wanted to change my age to 28 or 29, notice we no longer get an error. So your rule should be always use const unless you have a good reason. A good reason would be, well, this value will change. Not, we might use it for someone else later. That would be a bad reason, is, well, right now this is Deandra's age, but maybe it's going to be someone else's. That might be a little confusing. But if we know that, well, my age is going to change, that would be a good reason to use let. So use const unless you have a good reason. You guys have also mentioned var. Var is another way to assign variables. It works similar to let. My rule for you guys today is don't use var. So var used to be the only way to assign variables. But at this point, if you're going to be programming well, I would stick with these two. So stick with const and let. Just be aware you might see var out in the wild. So just leave that one alone. And yes, there are some subtle differences between var and let that have to do with scope. We will not be talking about scope tonight. So as far as you guys are concerned, const should be your default. Let should be used when you have a good reason to. And var is just something you should stay away from. But if you see var, don't be afraid of it. It works very similar to let. All right, so that is the very quick crash course in the different ways to declare variables and the different data types. Can I put comment descriptions? Sure. So this is string, number, Boolean, and null. All right, we do have to go pretty quickly tonight, but this will be saved, and I'll share this again with you guys later if you want to refer to it. Null is a stand-in for missing data. So if we are not sure whether or not I have JavaScript knowledge, we might put in null. I should probably change this. Let's do this as, what don't I know? We'll put address equals null, since you guys don't need to know where my address is. This is actually a common one. If something like address data might be missing, you could assign that to null. Yep, like a placeholder. I will not be discussing null versus undefined. There is a difference between them, but we just don't have time to get into that level of detail tonight. So that's something you could look up on your own, or maybe later down the road we could talk about it. But there is a subtle difference. Just for now, know that they do basically the same thing. All right. Null is not true. So null is its own category. It works similar to false than true, but also that's another more advanced topic than we need to get into tonight. Okay, any quick questions about these data types or declaring variables before we move forward? All right, let's talk about the console. Well, first of all, I want to give you a little bit more insight into how this replet thing works. So I'm going to put a couple values down here. So we'll do I'm getting kind of crazy here. All right, so I have on 6 different lines of code, I've just kind of typed out 6 different values. Notice that none of these are stored in a variable. So while this code that I've written here isn't technically syntactically wrong, it's kind of silly because we couldn't reuse these anywhere. But I've typed out these values. So if I pressed play or go or run on my replet, I guess run is probably the right word. If I pressed run on my replet, what would pop up over here? It wouldn't be an error because this is all technically correct JavaScript. We are missing a semicolon here. Semicolons are encouraged, but don't actually, when you leave them off, they don't actually throw errors. So get in the habit of using them, but you'll find that if you forget, they won't throw errors. All right, so someone is suggesting this last item would appear over here, and that is correct. So this is replet-specific behavior. So this is one of the downsides of using a sandbox. This won't be true everywhere else, but what replet specifically does is it will show you the result of the last line of code. Now, the reason it does it is because if it showed you every single thing on here, it would start to get kind of cluttered. So replet has just made a design choice to show you, and I think you can potentially change this in settings, but it will show you the last value. So if we typed address as our last value here, what would appear in green? So now the word address, null, because address points to null. So just be aware in replet that the very last value you type will appear in green and nothing else. However, sometimes we want other stuff to appear. So if I wanted to see multiple values, I could always use something called console.log. So if I said console.log fascist leader and console.log address, now both appear in white. So console.log is not replet specific. This is actually designed for use in the browser. So console.log is a tool because JavaScript is meant to be run in the browser. This is our way of literally making things appear on the console. So as a reminder, the console is in your developer tools. You have your elements, which we've worked with a bunch. We also have our console. So in Replit, instead of having to literally open the console, they basically do a fake out console. So you don't really need to understand this all at a deep level. Just be aware that if you want to see what a value resolves to, or you want to see some code in action, you can always pop it in the console.log statement and it will appear over here in white. So this is just a guide of how to use Replit. So white is going to be everything that we put in a console log. Green will just be our very last statement. So there you go. So we will be talking more about console logs later because they're a really good way of debugging our code. And there'll probably be a lot of help on the challenge tonight if something isn't working and you need to figure out why. So what you need to know right now is that Replit will show you your last line of code in green, or at least the result of it. But if you want to see more stuff, you can pop it in a console log statement and it will appear here in white. All right, let's move on to if-else statements. So this is another thing that you are going to see in every single programming language. We'll be focusing on the JavaScript version, but this branching stuff will appear in any programming language you learn. All right, so the idea of an if-else statement is sometimes we want our code to behave differently depending on conditions. So we might say if fascist leader, console log, overthrow the leader, else okay. So let's take a look at what I've just written here. And even if you've never seen an if-else statement before, I bet you could just kind of guess, based on these words, if and else, what this bit of code might do. Does anyone, especially anyone who is not familiar with if-else statements, can anyone guess what this code might do here? Any ideas? It is going to print out something. Will it print, how about this? Is it going to print out both of these statements? When I run this code, do you think we're going to see both of these statements run? No, so it creates a choice. It's saying do this behavior or do this behavior, one of the two, depending on some condition. So in this case, it's saying print overthrow the leader if we have a fascist leader, otherwise print everything is fine. So what we can do is if we actually changed fascist leader to false, we'd see a different statement. So this is getting into the true power of programming languages because now we have the ability to branch, to tell the code to do different behaviors depending on different conditions. So the takeaway here is that we use the keyword if. We have some sort of condition here, and then following inside of these little brackets, we can do one behavior, and in our else statement, we can do a different behavior. Yep. So this is resolving to true and false. And as I see Joshua mentioning, it can get a little subtle what actually can go in this if statement, but I want you guys for now to focus on just whatever goes in here is going to be true or false. So we could also do something like if age is less than or equal to 30. We can do comparisons. Anything that's going to resolve to true. Yeah, and I would say I'm also going to, I kind of said this already, but for those of you who have extra knowledge here, I think it probably hurts instead of helps when you jump ahead to a different concept inside of the discussion channel. So Once again, if you're ahead on this, that's awesome for you, but try to limit the discussion to what we're actually focusing on right now. All right, so we have, okay, question. Can you put the else on a new line? Okay, this is actually a general statement. So as with the other languages we've seen, this could all go on the same line if we wanted to. As far as the computer is concerned, we don't need white space, we don't need new lines. So this will run exactly the same. But please do not write your code this way, because it will be awful for you and all the other humans involved. Just because the computer doesn't mind doesn't mean that your future self or your fellow programmers won't. So make sure that you are using new lines and you're indenting, just like we practiced with CSS and HTML. The compiler doesn't care, but your fellow humans will and your future boss will. Okay, if the question is what will return true apart from true, that's a really complex topic. So focus on, for now, comparisons or just something that's actually set to true or false. But be aware that there's actually a lot of other stuff that can resolve to true, just outside of the scope of our topic for tonight. All right, so that is if else. Also be aware that you don't actually need an else. You can just do an if. So in this case, you don't want a default behavior. If it's true, it will log. If it's false, there's no behavior. All right, any questions about branching? And once again, I've said this about a lot of different topics. Don't feel like you have to memorize the syntax. You can always look up how to write an if-else statement in JavaScript. It's going to be extremely easy to find something to reference that. The important thing I want you to take away is understanding what an if-else statement is and when we might want to use it, because you'll easily be able to look up the syntax for reference. We will not be covering switch statements. So switch statements are a different form of branching. We won't be covering them. Anything you need to do, you'd be able to do using if-else, and that's always a topic you're welcome to pursue on your own if you're curious. Yep, and it's true that you can also do multiple options within something called an else if, which I also will not be covering, but is something that exists. All right. So let's talk about looping. If else is good for branching, so when you want a decision tree. Looping is good when you might want a similar bit of code to repeat itself. So I'm going to go over a for loop. Well, let me leave this here. So let's do a for loop. There are multiple ways to loop in JavaScript. My personal favorite is something called a for each, which we will cover in a later lecture, but we're going to focus on probably the most versatile loop, which is the for loop. All right, so let's say that we wanted to console log hello world 6 times. Well, I could say console log hello world, and I could copy and paste it. That's 6 times, and that would work. So I've just literally typed in 6 copies of hello world. But why is this bad practice? Why would we probably not want to write this into our code base? It's not dry. Yep, so we're going to be, this concept of dry, don't repeat yourself, is going to come up a lot now that we're in JavaScript land. So if I wanted to change this, let's say, to hello world, I would have to go in and change it every single time, and that's really annoying. So bad programming practice. So let's go ahead and set up a for loop to do the same thing. So I'm going to write this thing out, and then I will break down in detail what is going on here. So what I've just said, and once again, I will break this down in detail in a moment, is repeat this 6 times. So notice, same behavior, but I've only had to write the log statement once. So now if I want to change it, I can change it in one place, and ta-da. So looping is used when we want to either have the same behavior exactly repeated or a slight variation repeated. Let me break down for you how this works. So a loop works with an index. And generally we use this variable I for our index. So the idea is that this chunk of code in between the brackets will be repeating. And we can kind of tell because we see that we've written this once, but it's happened 6 times. So everything in these brackets will be repeating. And in order to keep track of how many times it should repeat, we're going to use a variable called I. So we use the keyword for, and inside these parentheses, first we're going to initialize our index. And we always want to use the keyword let when we're working with a loop, because our index is designed to change as we loop through. So you would never want to use const on a loop because you would get into some trouble. This index is meant to change. Our default starting point for I should be 0. There are certainly cases where we might want a different starting point, but the default should be 0. So we're going to say start our index at 0. Then we're going to say, basically we're asking the question, should we continue? And in this case, we're saying, yes, continue as long as I is less than 6. So we're going to keep running this code as long as I is less than 6. And then the final piece of this is we make a change to I. So when we do this plus plus operator, all that means is increase I by 1. So this is a shorthand in JavaScript for increasing I by 1. So what happens is we start off with I at 0, which means we want to continue because it's less than 6. We run this code once, then I increases. Then we check if our condition is still met, we run the code, and then I increases. And so on and so forth. So we will do this 6 times. So a good shorthand is start this at 0, make this less than however many times you want to loop, and then put whatever code you'd like in here. So that is how a for loop works. Okay, so if I were to throw console.log I in here, I'll get rid of hello world. And without running this code on your own, what do you think we're going to see logged to the console? Yep, so 0, 1, 2, 3, 4, 5. Now this is a little unintuitive because we kind of want to see 6. But remember, we're starting at 0. This is something you'll see across the board in programming. We're starting at 0, and it'll continue as long as I is less than 6. So once I hit 6, this fails, and it'll quit. So we never actually see 6 logged, because when it hits 6, this will fail and we'll never run this code again. So this is kind of our standard rule, is that you'd expect to see 0 through whatever is less than kind of our upper limit. This, if your head is hurting a little bit, it's okay. You will get used to this soon and you'll be able to do loops in your sleep. And yes, once we talk about arrays a little later, this 0 indexing thing will come up again. All right, so let's, I want to give you guys a little practice with loops, but let's pause for a minute. Any questions about anything? Well, let's focus on loops. Any questions about loops before I let you guys work on a little loop challenge? So this I++ will run after the code. So essentially what we're doing is this runs once at the very beginning. This will check before the loop runs, and then this will execute after. So the first time we run it, it's 0, and then we increment for the first time. And yes, there is also a ++i, which is subtly different, but I wouldn't worry about ++i versus I++ right now. I++ is pretty standard for a loop. All right, any other questions about loops before I let you guys work on your challenge? All right, so here is the loop challenge. I'll give you guys 5 minutes to work on this. Just be aware, don't mess with any of the console logs. You should see, what you should see if you write this loop correctly and press run, you should see alakazam logged 4 times beneath challenge 1, and the numbers 1 through 5 logged beneath challenge 2, and so on and so forth. So just write your code for each challenge where it says code here. You're welcome to fork this and save it. Otherwise, you can code right into it, but you won't be able to save it. So actually, I don't know if you can code into it and REPL it. I think you'll have to fork. So I'm going to post this in the main channel in Slack. I'll set the timer to 5 minutes. I will leave this up for reference. And we'll come back in 5 and I'll go over the solution. All right, good luck. All right, just a few seconds left, and we'll go over the solution. All right. So as with everything in programming, and certainly with loops, there are a lot of different ways we could do this. So I'll show you a couple variations for some of these. So let's start with the first one. This is very similar to what we already did with Hello World. So when we want something to loop 4 times, the easiest way to accomplish that is to start our I at 0 and then make sure I is less than 4. And as Virginia figured out the hard way, one of the most common syntax errors is to put a comma in here instead of semicolon. Just make sure these are semicolons. So, all right, if we want it to go 4 times, we know shortcut is start at 0, less than 4, and then I++. All right. And then we can just do a console.log, alakazam. So we run this, and there it goes. So this is a really good kind of starting template. So I'm actually going to do a little copy and pasting because writing out these for loops can get tedious. So for challenge 2, I want a loop that logs the numbers 1 through 5. So here's a question. If we want the number 1 through 5, how many times will this loop? We know that this one looped 4 times. How many times does this one loop? 5. So once again, a good starting point is to say start at 0 and I less than 5. Now it can be tempting to do console.log I. And so this is a good setup because we know it's going to loop 5 times. But we don't quite get the right numbers because now we get 0 through 4. So there's 2 ways we can fix this. To me, the easiest thing is don't mess with this because it can start to be a little bit of a mind melt once you start thinking about, wait, where am I starting? Where am I stopping? I would just console log I+1. However, as I'm sure some of you found out, this would also work if we said start at 1. You could do less than or equal 5 or less than 6 and logging I. So there's 2 different solutions to that one. I personally, unless I really have a good reason to, I always like to start my I at 0. So I'll just log +1 to bump it up. All right, so this one is a little more challenging. As I said, I like to start my I at 0, but sometimes it's just not going to work. So for this one, I'm thinking, okay, probably can't start my I at 0 if we want. We could get very clever here, but let's do something a little bit different. So I know the first thing I want to log is going to be 10, so we can start our I at 10. The last thing I want to log is going to be 1. So I'm going to say as long as I is greater than 0. So I have it reversed here. We're starting at 10 and keep going as long as I is greater than 0. And then as some of you guys either probably figured out or had to look up, just like we can do ++, we can do a -. So this one was a bit tricky because we're actually having to go in reverse. Yes, and you are correct that I could be anything, but stick with using I for loops because that's a convention. So you might end up creating, unless you have a good reason to, you're going to end up creating confusion if you use something other than I. So, okay, we have I starting at 10, as long as it's greater than 0, and let's throw a console log I in here. So now we have 10 all the way through 1. All right, finally, we want a loop that logs the numbers 0 through 5, but it skips 3. So there's a few different ways to do this one too. Let's start with this. We want to start at 0, less than 6, because 0 through 5, it's going to iterate 6 times. And then I++. So I'm going to start here. I know this isn't quite right, but let's just make sure we have 0 through 5 to start. So this is a good starting point because we have 0 through 5. There's just this one issue where we want it to skip 3. So the simplest way we could do this using the tools we already know is we could say if, so I'm going to show you maybe a more hacky way to do it, but this might be a good starting point. So we could say if I is equal to 3, and we actually have to use a triple equals to compare. So single equals is only used for assignment. Triple equals will compare. If I is equal to 3, then we can, well, we don't really want to do anything. So we could leave this blank. Otherwise, console log. So this isn't exactly how you would normally do it, but this will help you start to think about it. So if it's equal to 3, do nothing, otherwise console log. This will work. And if you guys did it this way, that's totally fine because we're all getting comfortable with this. So a few other, Elijah, what you did is a pretty good approach. So we could even simplify this and we could say, if I is not equal to 3, console log. So, oops. So in this way, we don't even need the else. We're saying as long as I is not equal to 3, console log. I think someone mentioned a continue statement. You could also solve this using a continue statement, but since I would say don't worry about that if you don't know what it is. So yeah, there are a bunch of different ways to solve these. And I will say that this is tricky because this challenge required you to use concepts that I had not taught you. We didn't talk about the triple equals or the not equals. We didn't talk about minus minus. That's really how it's going to be. There's a lot of subtle stuff in JavaScript, and there's no way we can go over all of it. But hopefully we're going to introduce you to enough stuff that you at least have an idea of where to go. So what I hope some of you guys did, if, for example, you tried to compare using a single equals and you had an issue, you can, you might say not equals JavaScript, or you might have said, and this would have taken you right to not equal operator, or you might have said decrease a number JavaScript. Oops, I spelled that wrong. Decrease a number JavaScript, and that would have given you would have seen, oh, there's a minus minus. So everything you do is going to, in pretty much across the board in programming, is going to require you to look stuff up. All right, let's go back here. So hopefully this gave you a chance to practice the basics of looping and also gave you a sense for some of the other stuff you can do and a little practice looking up whenever you need something that you might not know how to do yet. So let's, let me see what you guys, if there are any questions. All right, for those of you guys getting an error, you're gonna have to actually share. First of all, if you're getting an error, the very first thing you should do if you're getting an error is go to the line. It will tell you which line to check. So it's saying 32. It's not always exactly right because in this case, the issue is really happening up here, but it should give you a sense of where to look. It'll also, it says unexpected token curly brackets. So that'll give you an idea that one might be missing. So check the line of code it points you to and check the error message. If you still can't figure it out, actually share some of your code because we don't really have any information if all we know is you're getting an error. All right, even just saying that your error is for Alakazam, that doesn't really tell me anything about what your error is. I'm gonna actually have to see what your code looks like. So you can post that in the thread if you want us to take a look at it. And yes, all right, so a little hint on your alakazam code. It's up here in your for declaration statement. Keep in mind what I is supposed to be. I is just a counter that keeps track of how many loops you've gone through. So that's my hint. Take a look at your code up there. All right. And someone mentioned infinite loops. Yes, something to be careful with loops is if you set this up wrong, you can end up with an infinite loop. For example, let's say we swapped this. And it was actually, okay, let's try this. So I said, let I equal 0. Continue as long as I is greater than 0. Increase I. What is going to happen when I run this code? So we're starting our counter at 0. We want to continue as long as I is greater than 0. And we increment every time. So nothing will ever stop this. The good news is that, wait, as long as, actually we'll do as long as I is greater than equal to 0. Yeah, so there's nothing that ever stops it because I will always be greater than or equal to 0. This is what's called an infinite loop. Luckily, Replit will kill it eventually. It's still going. I hope I have infinite loop protection. I think we'll be okay. Please stop. There we go. I think they updated. All right. So yes, just be mindful. You're not going to destroy anything because computers are designed to catch it when you do this and stop it eventually. But yes, be aware that it is important how you set these up. Uh-oh. Come on, browser. Come back. Maybe I shouldn't have... Yeah, I shouldn't have relied on Replit. All right. Well, let's just refresh this. Or maybe even, okay. I'm going to open that up again. I may have not pressed save as soon as I should have. All right, well, I've given you a nice, very concrete example of why not to do infinite loops. So let's put this back the way it belongs, less than 6. All right, I will save this so you guys can reference it with solutions if you'd like. So you can just use the same link that's in Slack if you want to take a look at this later for reference while you're working on your challenge. Okay, so any final questions on looping before we take a 5-minute break? The Fellowship of the Infinite Loop. I like that. I would read that book, and then I would keep reading that book, and then I would keep reading that book. There is 4 of and 4 in loops. We will not be discussing them tonight, and you will not need them for the challenge, but they do exist. All right, final call for questions. Is there a difference for I plus as opposed to plus plus? Yeah, let's talk about that for a minute. Okay, so plus is a regular addition operator. So let's say we have, I'm gonna let I equal 10. So if I do I plus, if I just do I plus on its own, that's not a thing. This will error out. So I plus, so the plus operator, just a single plus, is meant to combine things. So if we tried to do this, we would get an error. But if we did I plus, let's say 20, this is going to give us 30. So this is like your regular mathematical plus. We're just saying whatever this is plus 20. Notice that this will not actually change the value of I though. This whole statement resolves to 30, and we could even store it in a new variable. So this would be equal to 30, but using the single plus will not alter the value of our variable. Whereas I++ is essentially a shorthand for saying I equals I plus 1. So these two things are the same. So that is the same as this. So it's just a shorthand for adding one and then storing it back in the same variable. So this actually changes the value of the variable, whereas the single plus operator by itself is just going to combine things together. All right. Do I have to learn all kinds of loops? It's good to be familiar with them, but I will say that I don't think I've ever used a while loop in real life. So there's something called a while loop. You don't really use it. You should know what it is, because it'd be kind of, eventually you should know what it is just to cover your bases. But almost all the time, if I personally am using a loop, it's going to be a for each loop, which we will learn in a later lesson. But for loops are pretty common too. So we don't have to learn all these together. Once you get comfortable with this one and get comfortable with the language in general, you'll be able to pick up the other ones really quick. Okay, so let's go back to another question on this was on challenge 2. So what's happening here is as we go through this loop, I is going to be equal to 0, 1, 2, 3, and 4. But because I'm console logging I plus 1, this statement does not change the value of I. It just changes what appears on the console. So as per what I just explained, this statement won't actually change the value of I. It'll just change what is console logged. So if we console logged I by itself afterwards, we're going to see something a little weird here, which is what we see I plus 1, and then we see I plus 1, and then I. So if we look at kind of the second row, or the second set of numbers, those are I. I'll even, to make this more obvious, I'll throw this in. So I'm just throwing strings in these console logs so they're labeled. So we can see there's I plus 1, there's I plus 1, I. So I isn't actually changing, it's just that something new is appearing on the console. All right, so let's go ahead and I'm going to give you guys a 5-minute break, and then when we get back, we're going to talk about functions. So I will see you guys in 5. And I will save this replit as well. So if you guys want to reference the code here, just click on the replit links in Slack, and you can look at the code from either of those. All right, I'll see you in 5. All right. Welcome back. Let's go ahead and talk about functions. So functions are, this is kind of, I'm just going to keep all the code in here. It's kind of a grab bag for you guys to look at later. So let's talk about functions. Functions are reusable chunks of code. So to give you guys reference, functions work very similar to mixins, which you're already familiar with. Whenever you have a single value you want to reuse, that would be a variable. But if you have an actual chunk of code that you want to reuse in multiple places, you want a function. Now, if you literally just want to repeat the same code over a certain amount of times, a loop is great. But if you want to be able to use the same functionality, wherever in your code base, you're going to need a function. So let's say that I wanted to console log hello WEBPT12. I could do that. It appears over here. Let me comment out these other console logs because they're going to drive me insane. So I will comment them out. There we go. So that's cool, but maybe I want to be able to say hello to you guys easily whenever I want to do it, anywhere in the code base. So that's where we might want to create a function. So there's 3 different ways to create functions. I'm going to show you each one. So let's start with this. Greet PT12. We'll just call it greet, actually. So let me move this in here. All right, so this is our first way to declare a function. We use the keyword function. We name the function, any non-reserved word, follow it with a set of parentheses, and then within our curly brackets, we can put whatever chunk of code we want to repeat. So this is a very simple function because it's only a line of code. But this could be, 10 lines of code, 3 lines of code, 100 lines of code. That would be a pretty intense function, but theoretically, we could have as much code as we wanted here. So when I press run, notice that the greeting, the hello world, doesn't appear anywhere. Does anyone, yep, and when I say non-reserved word, I mean you can't use a keyword like function or const, just any other word that's not built into the language. Yep, so the console log doesn't appear because this in and of itself is the potential to run the code. So this code inside of here will not run unless we invoke the function. So we've just created a function, which is like the potential to run code, but we need a function call to actually run it. So just like with mixins, we follow the name of the function with parentheses to invoke the function. And now it appears. So if I were to call the function 4 times, what do you think we're going to see in our console when I run this? Any ideas? We would see the console log happen 4 times. Because every single time we call it, this code will execute. So a common memory tool is just think of these parentheses as a button. You're not going to execute the function until you press the button. So if we just did greet on its own, it would say, okay, that thing's a function called greet. But the behavior doesn't actually happen until we call it. So it's important to distinguish the actual function versus the function call. So yep, you can think of a function as just a reusable chunk of code that you can reuse anywhere in your code base. If you wanted to, okay, question, is there a reason you'd want to use the function without the parentheses? Yes. I don't think I want to say anything more than yes on that. When we talk about higher order functions, which is, I can't remember the order. It's either on Thursday or it's next week. We'll talk about higher order functions, I think next week, and you'll see why we might want to use the function without the call. So that's a little preview of things, of coming attractions. Yep, sometimes, and a little short answer that if this doesn't make sense right now, that's fine. Sometimes you want to pass around the function without actually invoking it yet. And that's the type of stuff we'll do with higher order functions. All right, so let me show you two other ways to declare a function. So we could also, I will comment this out. We could also do constant greet equals function. So very similar result, different syntax. This looks more like how we've declared other variables. So we can do const greet and then assign it to this. So this here is called an anonymous function. You don't really need to know that yet. But we're essentially putting a function without a name and storing it in a variable. Still works. So that's another way to declare functions. And then we can also do an arrow function. So this is a third way we might declare a function. Once again, it's going to work the same. So this is a shorthand where we just, instead of using the keyword function, we just do this little arrow symbol. So this is arrow function. So these are, I can't have them all commented in on once because it would get mad at me for assigning greet multiple times. You can do all three of these. I don't want to spend a lot of time talking about the differences between, I don't want to spend a lot of time talking about the differences between these because we have so much other stuff to cover. And however, I will say one thing, which is that this syntax, the original syntax I showed you, one little cool thing about this is you can actually call greet above where you declare it. So most of the time in JavaScript, everything is read top down, but there are some exceptions. This is one. So this is something happens here called hoisting. So we can actually call greet above where it's declared. I don't want to get into the real differences between these three types of declaration apart from this hoisting thing because we have a lot to cover. Just be aware that there are three different ways to do this. And in the arrow function, what's happening is, sorry, let's let this save. What's happening in the arrow function is you don't actually need the keyword function. So if you compare this code versus this, instead of using the keyword function, we use the parentheses followed by an arrow. So you'll be asked on the challenge tonight to change, I think, some standard functions to arrow functions. Why would you put a function in a variable? Well, essentially, you're doing that already in this form because you are creating a variable called greet that points to the function. As far as the reason to do it this way versus this, once again, I don't want to get into the subtlety of that because we just have so much to cover tonight. So this is going to be one of those things that you can either look up on your own time or discuss with your TLs, or we can get to it at a later lesson if we have time. But just be aware that these two are going to work essentially the same, except that this hoisting thing, if we had it declared this way, we wouldn't be able to call it above. All right, so apart from questions as to the differences between the three styles, any questions about functions so far? Okay, so let's talk about parameters. Just like mixins, sometimes we don't want to exactly repeat the same lines of code, but we want some variation. So let's just do an add function. So function add. Wait, what have I done? No. I feel like they updated Replit differently, and I'm like, what are these little dots? All right, so just like you guys got used to in less, we now have put some parameters in here. So the whole magic of these parentheses is we can put parameters in them if we need to. So let's say we wanted to add up A and B. We can always do A plus B. So these are going to stand in for any two numbers that we might pass in. And then we can say add them together. So let's do console log A plus B. So this function is going to add, we'll call it add log, because we add two numbers together and then we log them to the console. So let's go ahead and call add log. So without running, if you're working with your own copy of this, don't run this code, but I want you guys to tell me, when I run this code, what are we going to see appear on the console? So I've called add log, just like with non-parameter functions, you still have to do the parentheses, but now we're passing stuff in. What are we going to see? Yep, so we're going to see 6 logged to the console, 5, and then 40. So we're calling this 3 different times with different sets of parameters. So just like with the parametric mix-ins, the behavior of this is going to be essentially the same, but it's going to change slightly depending on this. So be careful to make this as general as possible because we really want this to work no matter what two numbers are passed in. Yep, so let's, and I see that Jesus is insistently bringing up the difference between the term arguments and parameters. So let's discuss that. So parameters are similar to variables. So parameters are in a general sense, what should be passed in. So we would say that the parameters for add log are, we might say they're A and B, they're two numbers. Notice that when I describe these, I'm being very general. So the parameters are a general term for what do we expect to be passed in here. The arguments are specific. So these would be arguments, and they are specific values. So every function call has arguments. So a function declaration has parameters. And FN is short for function. So when we define the function, we're thinking about what are the parameters. In general, what are we planning on passing in? When we call, we're thinking about the arguments. So for every function call, the arguments might change, but the parameters are always A and B, whereas in this case, they might be 2 and 4. In this case, they might be 10 and 30. So this can be tricky because it's really easy to accidentally interchange these terms. I know I'm guilty of it, and you'll hear programmers accidentally interchange these terms. It's not the end of the world if you swap one for the other. But it is important that you know which one is which. So you need to know that parameters are general and arguments are the specific values that get passed in on a function call. Because if you're in an interview, you definitely want to have these terms straight. So that's the difference between the parameters and the arguments. All right, so let's talk about kind of the final piece of the puzzle with functions, which is the return statement. So, all right. So what we've been doing so far is we've just been console logging. And that's fine to have a function that console logs. A console log would be considered a side effect. It's like the function causes some other behavior to happen on the side. However, most of the time when we're using a function, we don't actually want a console log. We want, let me comment these all out so our console doesn't get too cluttered. We want it to return a value. So we want our function to actually output a result. So more useful than add log would be just a regular old add function. Instead of these values appearing to the console, we want them to be spit back out. So notice that I've now used a keyword called return. What I'm saying here is that when I call add, I want it to resolve to the result. So notice that over here, it was printed in white on the console, but when I called the function, it didn't resolve to anything. So now, and this is a really subtle point, but it's important. So now if I call add 2 and 3, nothing appears in white. Remember, white is the console, but in green, we see 5. So that means that this whole line of code actually resolves to 5. That means this is totally interchangeable for 5. So that's I keep using this term resolve. When I use resolve, I just mean it's interchangeable. So if we were to do this plus 10, what would this whole line of code resolve to? $15. Because this is going to resolve to 5, and then we'll add another 10 to it. So we get 15. We could also say multiply it by 10, and we'd get 50. So because we have a return value, because this function is now actually spitting something back out, get a result. And as far as PEMDAS goes, this will actually happen first because it's a function call. But if we just did 2 plus 5, we'd get a different result because now order of operations applies. But putting something in a function is like putting parentheses around it. It will always get resolved first. So once again, anything we could do with a 5, we could do here. We could do something like if add 2 and 3 is less than 6, this becomes interchangeable for its result. We can even store it in a new variable. So we could do result equals 2 plus 3. And now result will be the equivalent of 5. So this only works if we have a return statement. If I were to forget my return statement, then result would be, actually, what do you think result would be equal to? I've left out the return statement. So what do you think our result is now? Yeah, we're going to see a null, or it's actually, sorry, an undefined. So this does not resolve to anything. In other words, if we leave off a return statement, the result of this is going to be undefined. So most of these functions that you'll be writing need a return statement. This is very important to forget. This is saying we want output. So I use the console log example because it's nice to help get us familiar with functions, but be aware that almost every function we're writing is going to have a return statement. Another little gotcha is once this return statement happens, any code we write after the return is going to be ignored. So anything we write after our return statement is ignored. Notice we don't ever see this console log. So your return statement should always be the last line of your function. So return doesn't make it run. What makes it run is when we call it with the parentheses. It's just that it won't do it. Essentially, it doesn't resolve to anything if there's no return statement. Now, you don't always need a return statement because sometimes functions have side effects. Like if we go into an app world, maybe we have a function that triggers something on the DOM. In other words, let's say we have a function that changes the color of your buttons from blue to green. In that case, you don't necessarily need a return statement in your function because there's a tangible side effect. But when we're just working in the JavaScript world, most of our functions will have return statements. And yes, Joshua, I like your comment about, I understand a lot of this, but I don't think I'm going to recall it when I sit down. That is totally normal. I would be, if one of you guys is out there memorizing all the syntax as I go through it, I'm pretty much in awe of you. I don't expect any of you guys to be retaining all of the syntax. I want you to understand the ideas so that you can either look at my code or look at some Google references and be able to put this all together on the challenge. And yes, once you do this often enough, you'll commit it to memory soon enough anyways. All right, so I have a function challenge for you guys. Any final questions on this function stuff before I give you guys your mini challenge? All right, let's take a look at it. So I have created the shells of your function. So all you have to do is fill in your functions. And just like in the other one, don't mess with the other console logs here. Only write your code where it says code here, and you will see the correct results appear in your console if you've written this correctly. So we have, it looks like 3 different challenges. We have say hi, plus 10, and multiply. So these are all pretty straightforward. Just give you a little practice with this syntax. So I am going to give you, I think I'm only going to give you guys 3 minutes on this one. So I'm posting this link in Slack. I'll give you guys 3 minutes to work on it, and then we'll come back and go over the answer. Just a few seconds left to wrap up this challenge. All right, so let's go through this one. So the first one is say hi, and it says, write a function that logs hello world to the console. So in this one, we don't actually need a return statement. This one's going to have a side effect instead of a return value. So we can just do console log hello world. And then we don't have to worry about calling it because I've already written some code to do that for us. And we in fact see that this is logged correctly. So let's go on to challenge 2, plus 10. So write a function that returns a number plus 10. So we would want a plus 10, but notice that this specifically does say returns. So just make sure we put in a return statement so that plus 10 has a result. So when we run this one, we can see that our results appear correctly over here. Challenge 3 is write a function that returns 2 numbers multiplied together. Another one where we need a return statement, and this time we are multiplying. So if we try this one out, we see our results looks good. So this one's a bit more straightforward, just a little opportunity to practice some of the stuff and writing return statements. So any final questions on functions before we move on? All right, I will save this in case you guys want to reference it later. All right, so let's talk next about arrays. So let's say that I wanted to keep track of some of the students in this class. So I will pick on those of you who are being most chatty in the question and discussion threads. So I might say student 1 is Elijah and student 2 is Ian. Who else has been saying stuff? Student 3 is Joshua. This is what I do after class. I just create JavaScript variables to contain all you guys. All right, Stephanie is going to be the last one. So student 4 is Stephanie. All right, so this would work, but this is not good coding practice. Anyway, yes, the Supreme Leader is making a list. So why do you think that maybe this is, while this is technically correct, this is not great coding practice? Apart from the moral considerations of boiling down you beautiful, shiny, unique human beings to simple variables. So it's not exactly dry. Well, and dry is part of the problem, but this is where we have to think about the difference between a human mind and a computer mind. So for a human mind, we can clearly see that these variables are connected in some way. Student 1, student 2, student 3, student 4. Any human could tell that these variables have to do with each other. But a computer doesn't know that. From a computer's perspective, these are all separate variables that are stored in different places in memory that have nothing to do with each other. So when we have a collection of data that are related, we want the way that we actually store them to represent that, so that from the computer's perspective, these are all connected. So instead of doing this, we're actually going to do an array called students. So an array is what we use when we want to store a list of related items. So this array is called students. By convention, we want to name our arrays something that's plural. We declare them by putting 2 brackets together, or 2 of these hard brackets, and then we just separate the values by commas. So this array contains 4 different items. Notice that these are all strings. An array doesn't necessarily need to contain all the same data type, but it's a good rule of thumb. Once again, if you don't have a good reason Generally, you want to see arrays that contain similar data types, or else once we get into objects in a little bit, you'll see why. So all of these contain, did I say something other than strings? If I said something apart from string, I apologize. These are all strings. Oh, okay. Oh, I see. You're just talking to each other. Yep. Okay. So what data type is students? This is a little theory question. This variable, students, that we've declared here, what data type is this? Array. Yep. So it's tempting to say string because the array contains strings, but arrays are actually their own data type. So this thing is a collection. So now if I do students, in other languages, we have to specify what our arrays contain, not in JavaScript. So we wouldn't call it a string array because theoretically we could put something else in it if we wanted. So when I call students, it resolves to the entire collection. Now, what's nice about these is that there's an intrinsic order to them. So if we wanted to find the second student in the list, if the evil fascist machine said, bring me the second student, how would we look up the second student in here? Instead, I mean, we could print the whole thing and say, okay, this is the second one. We have to look it up. So there's a system of lookup, which is we follow the name of the array with brackets and then our index number. And you guys are probably going, wait, second student one. Remember, we are now computer programmers, which means we start counting at 0. So just like with the loop, whenever we're using arrays, we think of, and this will be annoying at first, and then you'll get used to it, we think of the first item as being index 0, index 1, index 2, and then Stephanie would be index 3. So we're just counting starting as 0. Yep, so our second student is going to be at index 1. Our fourth student is going to be at index 3. It'll be confusing at first, and then you'll get used to it, I promise. Okay, so using this indexing, we can access specific items. We can overwrite them if we want. So let's say that, sorry, Ian, you are getting replaced by Alan. So just like we would assign a variable, we can actually replace any of the specific indexes with something else in that same way. So now if we look inside of students, we see that Ian has been replaced by Alan. This brings up a question that a lot of people have when first introduced to arrays, which is, wait, yeah, the const, exactly. So why were we able to replace Ian even though this is const? So it does matter. Think of this as a container. So we are free. The whole point of the container is that we can add and remove and rearrange stuff as much as we want. So we are free to change the contents of this. However, if I were to instead say students and just try and replace it with a brand new array, sorry, Tommy, you're ending up in our array. Oops, Dennis. And let's say Justin. So if I tried to replace this with a brand new container, we'd get in trouble. So const does matter. We can't completely overwrite this array, but we are free to manipulate the contents. It's like we can't swap it out with a brand new bag, but we can reach in and take stuff out and put new stuff in. An array does not necessarily have to be a const, but as with anything else, stick with const unless you have a very good reason not to. All right, so let's talk about length. So one cool thing we can do with arrays is we can always find out how long it is with students.length. This is called a property. So it's something that we access on a variable with dot. So we're saying that every array is going to have a dot length property. And that will just tell us how many are in there. So length is, there's no offset with length. Length is just how many you would count on your fingers. So even though our final index is 3, the length is going to be 4. This will be very useful, especially when we loop through these things. All right, so what if I wanted to add someone to the array? Let's say, Alyssa. Let's add Alyssa to our array. We don't want to replace anyone. We just want to add her in there. How could we do that? Any ideas? We could use, there's push is a good way to go. Let's try and do it without push. Any thoughts on how we could add her in there without using push or any method? I think you guys might be slightly overcomplicating it. All right, I'll show you guys. And so there we go. So we can always just say, okay, we know that the next blank spot is 4. So let's just go ahead and put her in there. Is that, now I'm like, how do I spell Alyssa's name? Okay, I think I got it right. So we can always just put her in there. And then notice that now our length has gone up to 5. So this works, but it requires us to know how many items are in here. So there is a shortcut for doing this, and that is a method. So some different data types have things called methods on them, and they're essentially built-in functions. So all arrays have this built-in function called push. So if you do array name.push and then pass a value in here, we could add Alyssa in, we could push in, let's put Jesus in there. Let's put, I apologize if I say your name wrong, but let's put Naja in there. That's a cool name. So yeah, notice that I don't have to even think about the index. I can just push and they'll be put in the next available spot. So now our length is up to 7. And if we take a look inside here, we can see that everyone I've pushed in has been added in order. There's also a method called pop. Pop will remove the last item off and return it. So if we do students.pop, we can always get out the last person in here. So if we did students.pop, we would see Naja come back out. And then if we looked inside of students, we'd see that that entry has been removed. Okay, question, why wouldn't you just add them to your original array? In this example, you could just do that, but we have to expand out and think about how this might work in the real world. So this array might be declared somewhere totally else. So it's not necessarily true that this is happening right after the array is declared. It might be coming from somewhere totally else, and then we want to later alter it. This also might be a function where we, if some new data point is submitted to us, we want to add them to the array. So it's a little hard to see how this would work in context because we're just using such a simple example. But the more you work with this, I think it's going to make sense why you would need to push things in later after the fact. Yeah, like if a new account were created on your site, you might want to do a .push to add it to the existing collection of people. All right, any questions about arrays? All right, so let's go back to all the stuff we did at the very beginning. All right, so we could, at the very beginning, I collected some information about myself. So instead of keeping, these are all related, right? So instead of putting these all in separate variables, now that we know about arrays, we might say, we might call this all leader, and we could create an array and put a name, put an age, well, let's be honest, I'm totally the fascist leader, and then null for address. Hey, I'll totally leak my address because I have a P.O. box. This is me basically saying, if you want to send something bizarre to my P.O. box, I'm open to it, preferably tea. So there we go. There's my address. You won't be able to find me. Well, if you hang out at my P.O. box long enough, you'll be able to find me, but that's pretty creepy, so don't do that. I want to get more stuff than the water bill, so I'm leaking my address. All right, and please don't send arsenic tea. That would be very rude. All right, maybe I need a poison taster. You know you've really made it in life when you think you might need a poison taster, but I digress. So here is the information about me. Why is maybe an array not the best way to store this data? It is all connected, but it's kind of random and disjointed. And notice that without this code here, it could be very confusing. We don't know what maybe this is my age, maybe this is how many cats I own, maybe this is how many bodies are buried in the yard. We don't know. We definitely don't know what the true refers to, and we could probably guess this is an address. But this is not really a good set of data to store in an array because it's all kind of separate and it's confusing. So this is where we might want to use an object literal. So an object literal is similar to an array in that it's a collection of items, but it allows us to label things. So instead of being indexed with just this is item, the first item, second item, we can actually label everything in here. So we'll call this bad use of array. And then down here, we might instead do an object literal. So we declare an object with the curly brackets, and then we do key value pairs. So we could do name. We'll change this to body count. Fascist is true, and then address. So this makes a ton more sense than the array, because now all of a sudden it's very clear what each of these values refers to. So the difference between when to use an array versus a object literal is if you just have a list of items that are all pretty closely related, and if there's an order to them, that's a great opportunity to use an array. But if the data is a little more random and it could benefit by labeling, you probably want an object. All right, so yeah, and now we're all just discussing serial killers. Fun fact about John Wayne Gacy, one of my friends here apparently used to collect things that belonged to John Wayne Gacy. He was an antiques dealer and he had one of his clowns, which is kind of cool and kind of awfully creepy. So if anyone does decide to come stalk me in Bisbee, I can always introduce you to my John Wayne Gacy fanboy antique dealer friends, but we're all a little crazy out here in the desert. All right. So let's go back to object literals. So okay, if we want to look things up on here, we can't do this indexing anymore. What we did with arrays doesn't really work. We get undefined because objects don't have a built-in order. So instead, we need to actually look it up based on the values here. So if we wanted to see the name, we would do leader.name. Or we could do leader.bodyCount, so on and so forth. So that's really a good way to look things up on an object. You can also overwrite this if we needed. Let's knock this up to 128. That's a little more of an impressive body count, though definitely not Pol Pot levels yet. Okay, so we Yep, so we can always reference the name of this and see everything inside of it, or we can see individual items. We also can look up things using bracket notation, but for what you'll need to do tonight, dot notation is probably the way to go. So I'm just going to focus on dot notation. So yep, the difference between an object and array is that in an object we have these key value pairs, and you can look things up instead of by index, by actual value. So any questions about any questions about objects or the difference between objects and arrays? Yes, you can have an array of objects, and that's one of the last things we're going to talk about tonight, because you will have to be working with an array of objects at the end of the day. Yes, and just like with an array, you can change the inside of this as much as you want, but you can't overwrite it. So we couldn't reassign this to, if I was like, you know, let's just make it my name. That doesn't work, but we can change the inside as much as we want. We just can't overwrite it with a brand new object or anything else. Is there a way to show an entire object without showing the curly brackets? Yeah, you would have to loop through it and log things. I don't think I'm going to show you how to do that though, because that's kind of a tangent. But I don't know what, I mean, the curly brackets should be fine. They help indicate that you're working with an object, so it's good they appear. I am so happy about what just appeared in Slack that I'm just going to put this up here for the world to see. I gotta replace these with, there we go. All right. So if you tried to do leader with parentheses like this wouldn't work, because this indicates that this thing is a function, which it's not. So if we tried running that, we'd get an error, leader is not a function. So you can't call things that are non-functions. If you did console log leader, you would just see the entire leader appear in white in the console. If you put the semicolon in here, you would get a syntax error because it doesn't belong there. All right, let me give you guys a array and object related challenge. We are probably going to go a little over time, so I'm sorry this is a bit of a long lesson today, but I want to make sure you're prepared for the challenge. So I'm going to give you one more challenge. We're going to briefly cover another topic, go over the homework, and then we'll probably be done 6:45 or so. So you'll have just a little bit of time to go over the homework before the end of tonight. So let's go to, uh-oh, I'm missing one of my, but you will all earn an extra quarter of a potato in rations for your extra time spent. All right, so at the top, I have this array of birds and then this bald eagle object. So you have, I think, 5 different challenges of different fun stuff you can do with these. So once again, just code where it says code here and leave the console logs alone. So I will give you guys 5 minutes to work on this one, and I will go over the solution in 5. All right, just a few seconds left. Actually, I'm going to impatiently end it 10 seconds early because I can. So let's take a look at what we've got here. So we have this array full of bird names and then this bald eagle that contains some long Latin taxonomy stuff that I can't pronounce and stole from Wikipedia earlier. So the first challenge is to log hummingbird to the console by looking it up in the birds array. So if I look up here, hummingbird is the second item, which means index 1. So we can just do console.log birds at index 1. And because this is interchangeable for the value, I can just put this directly in the console log. And we see hummingbird is logged. Next, we want to replace Oriole with woodpecker. So Oriole is going to be at index 2. So we can go birds at index 2 and just assign in woodpecker. And then when we run this, we see that it has been replaced. Next, we want to add goldfinch to the birds array. There's a few different ways to do this, but really the push method should be your go-to way to add a new entry to an array. So we could do birds.push and add goldfinch in here. And we see that everything's there, and now we have a goldfinch at the end. Next, log the scientific species name of the bald eagle using the object. So we see that bald eagle has a species property. So we can go down and just console log and pass in bald eagle.species. And there it is. And then our next challenge is we want to add the family of, I'm not even going to attempt to say this, to the bald eagle object. So I will go bald eagle. I'm not sure if I showed you guys how to do this, but to add a new property, all you have to do is write out family and then assign in a new value. Accipitridae? I don't know. I studied Latin once upon a time. I should theoretically know how to pronounce that. And there it is. So we just add a new key on here and assign it in. Yeah, I think this is a good alternative. It's also in the spirit of the next thing I'm gonna show you. So there you go. I will save this so you have this for reference. All right, I'm not gonna pause anymore for questions until the very end because we are getting low on time. There's a few more things I want to cover. So I do want to talk about how all these things come together because the homework will involve all these concepts kind of mixed into one. Oh yeah, you're right. It is atoms with 2 Ds. This is important. Thank you. Okay, so I have one last replit called monsters. I will post this in the main channel in Slack. So what I have here is, let me even pull this out so we can see it better. So I have an array containing objects. This is something that you'll see a lot when you're working with data, and you'll see it in the challenge for tonight. So we have this array, and each contains one of these monster objects. So they all kind of have the same different keys, but there are these 4 different objects inside here. So question, do I have a secret love of tabletop gaming? It's not a very big secret, but yes, I do. All right, so, and I have a very lovely large table, which is, I have a tiny house, but I bought like probably a exaggeratedly large table because I wanted to be able to play games on it. All right, so we have an array full of these objects. So if I wanted to say, let's say I wanted to see the swamp monster object. So I wanted to access the swamp monster object. How would I do that? Any thoughts? Don't overcomplicate it. The same rules of arrays apply. Yep. So we would just do monsters at index 2. But here's where it gets complicated. What if I wanted to see the weakness of the swamp monster object specifically? Not the whole swamp monster. Yeah, I could just do weakness on here. So we can chain these things together. So there we go. So all the rules apply. They just kind of stack on top of each other. So don't be intimidated by something like this, because you know all the pieces. You just have to put them together. I want to show you a couple other things with this that will help you with challenge for tomorrow. So I want to show you looping with arrays. It's pretty easy to loop through an array. So as a reminder, I know we've covered a lot of ground since loops. We always want to start I at 0. And what do you think I should be less than? If we're looping through an array, what should I be less than? Any thoughts? The number of items. So we can always do our array.length. And because of 0 indexing, we don't have to subtract 1, just less than length. So this is something that's going to become second nature, is you start I at 0, less than your array length, and then I++. So now if we want to say console log monsters at I, we'll get a console logged list of our different monsters. So one thing we might want to do is, let's say we wanted to create a new array just containing their names. So we could always create a new array called, let's call this thing monster names. We'll start it out as being empty. And then inside of here, we might say monster names.push. Here, I'm going to separate this out, actually. Hold on. So this will give us whichever monster we're currently on in our loop. And then we can always do monster names.push monster.name. So this is called mapping. And we'll go over a different really cool way to map in a later lecture. But this is called mapping. We're essentially creating a new array. And you will have to do something like this on the homework. So I just wanted to give you a quick example. So we actually created an empty array. And then for each monster in the loop, we went ahead and pushed that name into this array. So we've actually watered down this really complex data into a simpler array just containing all of their names. Yeah, I've mixed up single and double quotes a little bit, which is from a style. Oh, I see that I have weakness. Yeah, the key does not need to be in quotes, but if you put it in quotes, it doesn't matter. I don't know why I did that. Probably because I was going quickly and trying to get it ready. Yeah, so this type of thing, I just wanted to give you a little example of how you might do this. All right, I'm going to show you one more thing, and I know it's the end of the night and your brain is full of info, so you might have to look this up later, but I just want to introduce it to you. So one thing that will help you on the homework for tomorrow as well is sorting. So something else we can do is sort. So there's a really easy way to sort. And it turns out that every array has a sort thing. And what you do is, this is a little advanced, but you can actually put a sort function in here. So you can say XY. I'm kind of hurrying through this, but what you could do is actually say return, let's say X dot, what is this property? Danger level. So yeah, I'm hurrying through this, so you probably want to do some reference on this type of thing. But what happens here is I'm essentially saying for every pair of monsters, just compare their danger level. So if we run this, we see that we actually end up with a version of our array that's been sorted by, so we have the vampire at the top and the swamp monster at the bottom now. So this will actually give us a new array. Oops. Sorted monsters. So this is the kind of thing that might help you on the homework as well. All right. So those were kind of the last things I wanted to show you. I'm going to go over the actual challenge for a little bit tonight, mostly tomorrow. And then I will open the floor up to any questions. So those of you guys who want to leave can, and those of you who want to stay for questions can as well. So this is the, let's go to, this is the assignment for tonight. I'm posting it in Slack. I'm going to fork it. And go through a little setup stuff with you guys. This is all written out in the README. So if you're completely brain dead, no worries. This is all in the README, but I want to show you guys this. All right, so I will clone this. All right, so let me check out a branch. All right, so we are going to have to do an npm install. And essentially what that means is that this code base relies on outside libraries. So you don't have to worry about what those libraries are or what they're doing. All you need to make sure you do is run the code npm install before you use this, or else it's not going to work properly. So this is something you will very much get in the habit of doing with almost every code base. It'll take a minute for everything to install, but this is a necessary step. So let's give it a minute to install everything. Yes, you can also use Yarn for this if you prefer Yarn. You will need to, yeah, so every single project you have to do an install, but once you've installed once, you might install specific new libraries, but the big install happens at the beginning. All right, so this will make it available to run your JavaScript test code. So a little reminder of a question I asked at the very beginning, which is, how does JavaScript run? Every code, every language we learn, we can type it out and type out all the syntax, but there needs to be some way of it running and executing. So what are some of the ways we can run our JavaScript code? Do you guys remember this from the very beginning? Yeah, the standard way to do it is when you're really using it with HTML and CSS is you link it to your HTML. But this is standalone JavaScript. So we actually need to run it using Node. And we're going to use a test script to take care of that for us. So this script is included in the README here. But essentially what's going to happen is you will run this npm run test watch. So we talked a little bit about watchers, I think last week with Les. This is going to be a watcher that will watch your code and rerun it every time you change it with a set of tests that'll actually give you feedback on if your code is working or not. So just like with the Les Watch compiler, we want this to be always watching. And then if we need to do any git commits, we can do it in a different window. So notice that for all of our problems, right now it's saying, including stretch, there's 23 problems, and they're all failing. Actually, I think the very first one is passing. So 23 are failing, the first one is passing. So what you'll see is as you go through inside of index.js, and kind of like in the mini challenges tonight, you'll go through, read the instructions, and fill in your code. So you'll fill in each of these functions. And then as you save them, you should see that this will go from 1 passing to 2 passing to 3 passing, and so on and so forth. So this is a blessing and a curse. It's awesome because you get feedback, but I can tell you that this can get really confusing because there's so much going on here. So here is my recommendation to you guys. If you get stuck on a function and you can't seem to make it work, go ahead, copy it, create a new REPL. I'm not going to name this. If you're stuck on something, create a new REPL. Which is taking forever right now. And then bring this in here. So if you get stuck on something, it can, because there's so much going on in the assignments, I would highly recommend actually pulling it out and just messing with it over here and doing some console logs. You can do console logs in the homework, but there's so much going on in the console, it might be hard to see. So I would really recommend if you get stuck on something to put it in its own REPL, because it'll be a lot easier to work with. So that's my #1 recommendation for this homework assignment if you get stuck on something. Otherwise, just go through, do your best with these, get as many tests to pass as you can, and then go back through, and the ones that aren't passing, try and troubleshoot what's going on. You will need to work with data inventory. Notice that in this inventory file, there's a bunch of these car objects. So a bunch of the assignments work with this array of car objects. So this will just give you an idea of the shape of your data. So you can use this as reference. All right, my final word of warning on the homework. There are examples here, right? So in this it says, make person object. So for example, if we pass in 5, Leela, and etc. as arguments, this is where the difference between parameters and arguments become important. So in a lot of these, they've provided example arguments. But remember, when you actually write this, these need to be general parameters. So this is a really common mistake I see when people are first working with JavaScript functions. Just because we provided an example doesn't mean you should hard code in these values. These are just one possible set of values that this might take in. When you actually write the function, these parameters need to be general, and it needs to work with all types of things. So there's a lot going on here. Be patient, be kind to yourself. I don't want any of you guys going into the headspace of, oh, I can't be a programmer, I'm never gonna get this because this is hard. This will be hard. Unless you have outside experience, this will be challenging. That doesn't mean to give up or get frustrated. Just be patient with yourself and keep working through it. We only have 15 minutes left, and I know everyone's brain is very tired. So get it set up, tinker with it, but I think most of the work is going to happen tomorrow. And yes, I will make sure everything I did today is saved. I'll actually just repost all of them together and pin it. So you'll have some reference code, and please, please ask for help on this. This is a challenging one, and it's the foundation for what you'll be doing for like the next 9 months / maybe the rest of your career. So please ask each other, ask your TLs. If you need to, reach out to me. And I will do a Q&A, I think, tomorrow. So I will post all these links when we're done here, and I will also post some potential times for a Q&A tomorrow. So if you guys need help on things, I'll be available too. All right, any final questions? For those of you guys who want to drop and start working on this, feel free, but I'll stick around a few more minutes if there are any final questions. All right, we've been here for 2.5 hours, so I think it is time to call it a night. All right, thank you guys. I know tonight was a bit of a long haul, but we're laying foundation for lots of stuff, and I'll repeat these ideas as we see them again throughout the rest of this week and next week. I will see you guys tomorrow in the Q&A or on Thursday for our next lecture. Have a great night and good luck, and be patient with yourself, and send me tea in the mail. All right, bye guys.